All right. I don't know. Some humor, right? An invisible sneeze has 200 million germs, right? A droplet has 200 million germs. So hand sanitizer kills 99.99% of them. Right? That's what the bottle says. And so this person does the math. If you think about it, 200 million, get my zeros right, times 0.01%. What do you need to do to this before you multiply? You need to divide that by 100, right? So that'd be 0.0001. So that's still 20,000 germs are still alive, even if it claims to kill 99.99%. So the person says, ew. Right? And I don't know, I'm not proud to admit that I watched this movie, but when I was younger, I didn't know any better. Dumb and Dumber. Anybody watch that movie? Right? So this guy really likes this lady, and he's like, do you have a chance? You mean like 1 out of 100? And she's like 1 out of 1,000,000. He's like, so you're telling me there's a chance? And he's all happy, right? So, anyways, didn't read the situation right. Here we go. We'll do probabilities. So my guess is a lot of this is going to be review, but you still got to pay attention to, some of the twists, obviously, that grade 12 will bring to you. So the first thing is the rounding part. The rounding is annoying, okay? And I'll tell you what I mean with that. Sometimes the province says, hey, 1/3, write it as a decimal. Or they'll say 1/3, write it as a percentage. Okay? Or in words. Great. Okay. I forgot about you. And so what do? Let's get the words out of the way here. You can say 1 out of 3. And you can go even cheaper than that. 1 out of 3. I've never seen them ask for this, but they expect you to know how to do it. When it comes to these two, that's when it gets annoying. Okay, so if you want full marks, this is what you do. You take 1/3, and this is your calculator screen right now. This is your calculator. Okay, so you go 1 divided by 3, and obviously you get 0.3333, and that just keeps going. And here's the kicker. If you want to state this as a decimal, you got to go 0.33 because you're cutting it off after the second decimal. So you're omitting everything after it. That's would be the correct answer. If they want you to state it as a percentage, do not just take this and multiply it by 100. It'll be wrong. You got to go back to your calculator screen, take what's here, multiply that by 100, and now you round to 2 decimals, right? So that would be 33.33%. So we basically went 0.3333 something times 100, and then we answered that question. So you go to your calculator to answer that, you go to your calculator to answer that. So that's the annoying part, but that's how, if you want to get full marks, that's how you do it. 2 out of 7, for example. Let's do this one. This one is the easiest one. 2 out of 7. That one is an easy one. So here you go, 2 divided by 7. Write down what's on your screen right now. So write down at least 5 places or so, and then go dot, dot, dot. This is what's on your... All right, let's continue. So this was on our calculator, right? So if you rounded this to 2 decimals, what would it be? 2.9, right? Yeah. Because you cut it right here. Right? You're cutting it right there. But it's not 29%. If you stated it as a percentage, do not multiply that by, you go back to your screen, multiply what's on there by 100, and it's 28.57%. So I don't know if I'm making myself clear here. You go by 100 based on your screen. Do not go, like, don't go this way. Right? That is wrong. Okay? It is not 29%. I don't know if that stands out more. It is not 29%. Anyways, so that's a bit of a review. So you got that part. I think if you didn't get it now, we'll do so many examples that down the road you'll just be able to do it. Filling in a table like this, you're supposed to obviously move from what you have to the other ones. If you go from the decimal to percentage, I think everybody would agree, right? You just multiply that by 100. So if you multiply that by 100, yeah, 19.2%, correct? What about fraction? This is a blast from the past maybe for you, and maybe nobody taught it to you this way. I just tell my students, take whatever number you have in the decimal place, so it's 192, okay? And then just go 1 followed by 3 zeros. So the number of digits you have up here should equal the number of zeros you have down there. And you can check. If you go 192 divided by 1,000, you get this. Right? If you don't believe me, you do that and you will know that that's right. Okay. So what if you start here? Well, you got to go this way. So divide that by 100 and you get 0.3575. And then from here, you move this way. I always like my decimal before I state my fraction. So what will it be in this case? 3575. So 4 digits, correct? So I will just go 1 followed by 4 zeros. I don't know how to put this in words. I feel like it's going to just mess it all up. So I hope you just see the pattern. I'll use a highlighter. 3 here, 3 there. 4 there, 4 here. Okay. So that kind of goes hand in hand. And if you start fraction, I think that's the easiest one of all, in my opinion. You just divide. You go top divided by bottom. 185 divided by 237. And you'll go 0.78. Just that, right? 78, if you round it to 2 decimals. You could go 4. There's nothing wrong with rounding to more than 2, unless it's money. Money is the only exception. You have to round to 2 decimals. So what I do here is I take that and multiply it by 100. So I take what's on my screen and multiply that by 100, and it's 78.06%. Rounded. You want to give this one a try real quick? Write it as a fraction, write it as a percentage. Should be easy enough. Okay. You got this? 1, 2, 3, 4 over 1 followed by 4 zeros. And then this would just be multiplying by 100. So it's 12.34%. Bingo. You got it. Keep going. Simplifying fractions. We don't give marks for simplifying fractions anymore because your calculator can do that for you, to be honest. Like, for instance, if you have one like mine, if I go 28 and then I use this button right here that looks like a fraction, 42, like this, if I hit equals, it'll reduce it for you. So the province got rid of that, like, because because you all can do it. I use this button right here. So I go 28 and then press that button and then 42, it's reduced. So use this as your in your tool kit. This is why I'm going to tell you it may come into effect. This might be required of you to know is if there's a multiple choice question. So if the problem says, hey, this is the probability of a plane crashing, right? State the correct odds of that happening. They may not use these numbers. They may use the reduced version of it. So that's when you need to know how to do it. So I just showed you how to do it. Calculator. If you cannot figure it out, I will come and see you because you should be able to figure it out. Sometimes just going 28 divided by 42, when you divide them, you should recognize that 0.6 repeated is 2 over 3, right? That's another way of going. Or if it's 0.5, it's 1/2. Or if it's 0.75, that's 3/4, right? Like, so use whatever you can, use this thing, this is your tool to help you out. Moving on. So I'm not going to spend time on showing you that. I'll just do it as we go. Deck of cards. A standard deck of cards are used a lot in probability, obviously, because that's what's used to play games, right? I need you to have a small little deck of cards on your study sheet, but don't do it just yet. I'll show you one that I would recommend you have on there, which is 1,000 times smaller than this, okay? One thing you need to know is a deck of cards has 52 cards in total. Half of them are red, half of them are black, right? So that you kind of have a line right here cutting this thing in half. Then you have your 4 suits. So you've got your clubs and your spades, they're both black. And how many are in each suit? Anybody know off the top? How many cards in a suit? 13, yes. There are 13 in each suit, okay? So there are 4 suits in to say it that way, right? These are important to us right here. These are called our face cards. So the jack, the queen, and some of you need to have this written. I realize that not everybody plays cards. Okay, so I will try to help you out here. So there are 4 jacks, 4 queens, and 4 kings. In total, there are 12 face cards. Very important to know that. 12 face cards. So here's the short version that I'm going to give you. And hopefully this takes no more than a business card. Do you even know what that is these days? Do they still do business cards? I'm not sure. You can make this smaller. Okay, so from the 52, you branch off into 26 black cards, 26 red cards. So I'm mimicking the one you have up here. From these 26, you branch off like this. There are 13 clubs, 13 spades, and from the red, you branch off like this as well. 13 hearts. I would say just go CSHD, right, for diamonds. To make it even smaller. And then for every single one of them, you have ace, right? And then numbers 2 to 10. Sorry, why do I put 20 there? Sorry. 2 to 10, and then you've got your jack, queen, king. Every single one of them. Just copy this down so you have something to help you out. 2 to 10. Jack, queen, king. And I would do this under the last 3 here where you have the letters. Those are your face cards. Just write down there are 12 faces. Because I use face cards quite often. And I hope you understand how many kings are there? 4. How many red kings? 2. How many kings of diamond? Just 1. Right? So if you're king of diamond, you're very specific to just this one. There are 4 aces. How many numbered cards? Anybody? That one is tougher. There are, I have to do the math here, 52 in total, right? Take away the 12, that's 40. Take away the aces, you're down to 36. "36 number cards." So you know, like sometimes I do ask for number cards as well. So now you have no excuse. I think this is too big, to be honest. Like, it shouldn't take up that much space on your study sheet. If you can somehow make it smaller, please do so. Okay, so I'm gonna draw from this on ACs, on quizzes, tests. So have this on your study sheet. I warned you. Okay, so you know that every time I highlight a box, you're like, yep, I know what to do with that one. I made it smaller on mine, like it looks smaller, so you should be able to do that too. All right. Page 5. To be honest, this slide may make it more complicated than what it should. But just follow along, guys. Just follow along. There's a method to my madness, okay? Okay. What's probability? It's the likelihood of an event happening. We usually tend to go fraction. That's like my go-to for probability. And this box should be on your study sheet. What is probability? Probability of an event, so it could be raining, a plane crashing, you name it. There's a probability of that, a likelihood of that happening. What is favorable outcomes? Like, it's the outcomes that you want to find out. So if it's plane crashing, then you would figure out how many planes have crashed, right, over all possible flights that happened in that particular time frame. That's how you come up with your probability. And so I don't know why I'm using plane crashing, but there were a lot of planes crashing lately, so that's why I'm using it. A key concept to remember, so I just want you to remember, I don't want you to have this on your study sheet, okay, that the probability of an event happening plus the probability of the event not happening is always going to be 100%, okay, or 1. What in the world does this mean? The probability of the event happening, and watch this, highlight this part. You see this? What does the bar or the little tick mean on top of a letter? Against. So probability of the plane crashing plus the probability of the plane not crashing is 100% every time. If it's 60% chance of rain, what do we know about it not raining? 40. That's 100. Okay. So I'm going to do this at the top here, a pie chart. Let's quarter this up like this. If there's a 75% chance of snow, so always think of the 100%, your pie is the 100%. That's all you have in terms of probability. So that means a 25% chance of not snow. Or you can go snow with the bar on top. Okay. This is a very important concept. They add up to 100. 3/4 and a quarter, correct? Same thing? 3/4 and a quarter still gives you 1. So keep that in mind. I'm not going to talk about this right now. just this bottom part here. A fair game is considered a game that has a 50% chance of winning, which means you have a 50% chance of losing. If you see 0% chance ever, that is obviously impossible. If it's 100%, then it's certain that that's going to happen. So just some terminology that goes with it. Just got to move this up a bit. Okay. Example, there are 20 students in Mr. D's class. He knows that 7 of those students drive a car to school. State the probability of a random student driving to school. And by random, I always have to be random. Otherwise, it's not probability. If I kind of know who's driving, it's like, hey, I think, are you driving? Right? That's biased. So you kind of want to close your eyes, not know anybody, and just pick a random person. That's how probability works. So state the probability of a random student driving to school. You don't have to do this part down the road, but this is the proper way of doing it, the fancy way of doing it. You say, you go P with the, what is it that you're finding the probability for? We have 7 favorable outcomes out of 20 total. And let's state that as a decimal and percent. So I don't want you to go equals because we're going to round if we need to. Just go comma. 7 divided by 20. In this case, it's a nice finite decimal. So we're going to go 0.35, comma. You multiply your answer by 100 and round that to 2 decimals if you can. In this case, it's 35% even, so no worries there. B, state the probability of a random student not driving to school. Can you tell me without even doing the math? If it's 35% chance of someone driving, 65% not, okay? That is basically based on that pie chart I just showed you there. So 2 methods of doing this. So for B, method 1, we're gonna go 100 minus 35. So that's a 65% chance. Method 2, you're not going to like this one. Why so complicated? You should know what that means by now. Not driving. It's still out of 20, correct? How many are not driving? If 7 drive, 13, right? So I make it very complicated because I just like complicated. I don't like complicated, but I need you to see what's happening, right? So basically, every time you have the not, you're like, well, take it away from the total. So 13 students do not drive. And then you get 0.65, which is 65%. There it is. Right? Note, they add up to 100%. To me, this method here would have been much easier, quicker, just get to the point, right? So keep that in mind. All right, so this is just a word problem. I want you to go to page 6, and I'm going to put your grade 8 knowledge to the test here. Are you smarter than an 8th grader? That's basically. I'm just I know how the brain works. Okay, if you haven't seen it for a while, it kind of escapes. I'll do the first, maybe 2 random ones. So let's say this one. How is that random if you pick the first one, right? Just count, and please put a check mark on this. Like I start counting here, so there's 1, 2, 3, 4, 5, 6, 7, 8 sections. That is your total number of outcomes possible in this spinner. So every single one of these fractions, folks, is going to have an 8 underneath. I hope you know that. How many are red? So red 1, 2, 3, correct? 3 red sections. So there are 3 favorable outcomes. It wants you to go fraction, decimal, percent. So we're going to go comma, 3 divided by 8. You know what? I like to write them all out. If it stops, I just write the whole thing down because it's not wrong to do that. Comma, I multiply this by 100. So far, we didn't have to round, really. Is it okay to not have the 0 there, Mr. Dirksen? Because remember, with dollars, it's okay if it's not money. But if it makes you feel better, just put a 0 there, and then you don't have to, like, twitch or something like that. Right? I'll do this one. Probability of not yellow here. We know we have 8. Let's do it the hard way. How many are not yellow? There's only one yellow here, right? So 7 are not yellow. So I go 7. That's 0.875, which is 87.5%. Question, what would be the probability of yellow then, without this? We could just go 1 minus this, or 100% minus 87.5%, and you could answer that. But lucky for you, you've got a diagram, so you don't need to do that. Okay. So try to answer all of these, and then I'll go over, yeah, sure, you might have some that you can't do. Try it anyways for now. See if you can figure it out. I'll do my attendance in it. Because you're basically saying you don't care if it lands on either one of them. So we combine forces. We say, hey, there are 2 green and there's 1 yellow. So it's almost like your chances go up, right? Go to 3 out of 8. Blue or red, you add the blue and the red, and then you get your probability like that. So check. Yeah.
So if you're writing it out, do you have to show that you added it?
No. No, you don't. I just do it for your understanding, for you to see what I did there. Yeah, you don't have to show me that. And you'll also see, I don't know if you notice, like probability of not red. I go 8, that's my total, and I take away the reds. So I figured out that I have 3 red sections here. And so I kind of based it on probability of red. So I take it away. So I realized that it's 5 out of 8. And remember, not red and red, we can actually do that. We can combine and just say this one and this one should add up to 100%. Same with yellow, right? Yellow, like, the probability of not yellow and yellow is 100%. So this is how you know you're doing something wrong. If any of your probabilities gives you an answer that's bigger than 100%, you're doing something wrong. Something went wrong. That being said, like you would get 1 point something, right? Like you would have something other than 0 at the front as a decimal. So remember that. Because sometimes students put a bigger number on top than the bottom. It's like, it's not right. Can't have that, right? So keep that in mind. All right. One more section, and then I'll give you some class. I want you to be exposed to deck of cards, all of these things, marbles, spinners, all those things. Okay. So the prediction part. This is where, you know, you think most of you think probability. You think gambling. I'm thinking, or games. But probability is far more powerful for predicting things when it comes to, like, when government makes decisions, right? When the healthcare system, when COVID came around, that they kind of projected, like, how many patients are we expecting? When they do cancer, like, they know their cancer probability for people. And they're like, whoa, right? Like, we have, like, 30% of people are developing some sort of cancer. that means that we'll have like this many thousands of people coming into our clinic. We need to upgrade, we need to add more funding, and so forth. So for making predictions, that's where probability is huge. So I want you to, when it comes to making predictions, I want you to have this on your study sheet. When you get a sense that, hey, if this is true, the probability, then if you made, 1,000 of them, how much would you expect there to be, like let's say, products that have a defect? You find out that it's 1 in 100. Well, if you make 50,000 of those, how many would you expect to have an issue? Right? How many of those would have an issue? So prediction, that's what we're gonna do here. If you were to spin the spinner above 350 times, how many times would it land on yellow? So you're making a prediction. What's the probability of yellow? Probability of yellow, we'll figure it out in a bit, but this is what you would put in there, and then multiply it by 350. Okay, that's how many times you're spinning. So what's your probability of yellow? I don't have my, 1 out of 8, right? It's 1 out of 8. And so we just multiply that by 350 and see what we get. So grab your calculator. I would say put the brackets, or do what's in the bracket first, 1 divided by 8, and then multiply that by 350. And you get a decimal. Which in this context, you cannot have a decimal. Like the spinner has to land on either, right, red or blue or whatever other color. So we will say approximately 43 or 44 times. Either answer is fine. I know you were always taught to round up, right? If the 0.7, then this would technically round up, but the province would be okay with either one. One more time. If the wheel was spun 199 times, how many times would it land on red? Again, you're making a prediction. You will go probability of red times 199. Right? You're spinning it a bunch of times. So this would be, what's red? 3 out of 8. That's the probability of it landing on red. So you're going to see what is it in the long run. 3 divided by 8 times 199. So it's 74.625. Can't have that. So we will say 74. So it stays at 74 or bumps up to 75 times. And now it's time to see how much you've actually retained. Or maybe now you're going to ask questions that you didn't think of before. So I want you to go and work. I'm going to post the key as well. There's going to be a little bit of deck of cards. There's going to be chocolates. Hey, we like chocolates, right? Oh, most of us probably do, I'm guessing. So I will just say this. I don't know how far you will get. So I just made a whack load of practice questions for you. So pages 7 to 14, I think I have the key for that. So I'm going to go to page 7 and just say page 7 to 14. Try to do as much as possible. As much as possible. Let's